First of all, I just wanted to say was so flattered to do this talk, but I've also been quite nervous about talking to Carlo because I'm a big fan of his work, and I have been waking up with cold sweats, with serious sort of imposter syndrome today, thinking about how I'm going to talk about quantum mechanics for about an hour and a half, which does feel quite nerve-wracking. But I'm reassured to know that in the book, and one of the main points about this subject is that it does test the very bedrock of what anyone believes to be true, and what we assume to be real. So I'm sort of vaguely comforted by the fact that I don't understand it, but it's still quite nerve-wracking. I hope as an artist I can give a different perspective than maybe a talk between a scientist to a scientist. So I hope that my questions will have a validity and an originality. So anyway, so Carlo, I've read many of your books, and I think one of the wonderful thing that I think I find and people find so inspiring is this wonderful way in which you conjure these visceral scenes of nature, these sort of romantics of people, of human form in a natural setting, but then you intertwine that and you splice it, interweave it with these lucid descriptions of these hidden architectural worlds, these visualizations which are often quite counterintuitive of things that we will never see. And they are, to use a word that you use, they're breathtaking. And I just wondered, to take you now to the title of this book, could you take us to this rock in the Northern Atlantic and tell us why we're there and what it has to do with this subatomic world?
Thank you, Conrad. Thank you for this first words. Let me say that I am equally and symmetrically worrying and have worried about a conversation with you for exactly the same reasons. I mean, I love art. I love your art. But what do I know about talking outside the specific sort of technicalities of my own work? But I think this is a fantastic challenge. And let me start by saying this: there is something we know well, right? The things we know about the world very well. I don't know, the water is made by hydrogen and oxygen, and this is a pen, and my name is Carlo, and many things we know. And then there are things we just don't know, and I think we should happily accept the idea that we're ignorant about things. But then there is a boundary between the two, and the boundary between the two keep moving. And there are things we learn and things which fascinate us precisely because they're just outside what we know, and we have glimpses of them, and we a little bit start understanding. And in fact, if we think for a while, this is not a thin boundary, it's a huge boundary, because nothing of what we know for sure. And all things we don't know, maybe we can learn something about that. So there is this boundary where science lives, because that's what science is. It's not about what we know. It's about discovering toward what we don't know. And I'm not an artist. I'm just obviously, I am amazed by artists from a distance. But I think, to me, this is what art is doing also. It's sort of not telling us about, well, this is it. I mean, this is a picture of a chair, is a chair. What else is to do? Neither is incomprehensible to us, but is taking us toward this intermediate region in which is telling us that there is more in the things and in our relation with the things. So in this sense, I think art and science are extremely similar, with their immense difference, obviously. They are both ways in which we are learning new way of thinking about the world. We're opening new eyes somehow, slowly, toward the world. And to come directly to your question, this is exactly what happened, I think, in this scene, which it's at the opening of my book, which is when Heisenberg, Werner Heisenberg, 23 years old, in Helgoland. Helgoland is the title of the book, and is an island in the Northern Sea where Heisenberg first got a glimpse of what we call today quantum theory. And the book is about quantum theory, try to make sense about quantum theory. And he got the key idea of what later became quantum theory, became the formulas, the mathematics of quantum theory, and the concept of quantum theory. He had this idea. The result of that is the modern world to some extent. Quantum theory, it's at the core of our current understanding of reality. It's in a lot of our technology, almost in every aspect of our technology. But there is something still mysterious in quantum theory, still fascinating, because it has been a breaking toward some new understanding of the world, which I believe we haven't digested yet. So quantum theory is still at this boundary between what we know well and we don't know. And in the theory, I try to discuss as much as I can and say, what is that that we have understood about the world with quantum theory? What is actually that has come out from the intuition of Werner Heisenberg in 1923? Let me just close by saying that we have his diary or his memories about that night. The calculation things suddenly started to come out right. He was very amazed by that, a sense of emotion, a sense of glimpsing a new reality, a beautiful reality behind the veil of things. And he was very aware of a major step. In fact, I think it's a step of the magnitude of the Copernican revolution or Darwin revolution. And so he did all this calculation in the middle of the night, and then in the late hours of the night, he went out in the island. He climbed a rock because the island is very rocky, and from the top, overlooking the waves, the sea, he waited for the sun coming out, with the sense of having seen something that nobody had seen so far. A magical beauty behind the usual vision of reality. I think that's best of science, and that resonates with art a lot, in my opinion.
So then that's fascinating, and I love this idea of him in solitude on this solitary rock, and this vision. I suppose one of the things that, from a creative point of view, that I think you've explained it very well. But so if I get this right, he was working on the equations. The equations seemed to work, and he was suddenly realizing that they were kind of coherent, and that they were watertight. And then he went for the walk and realized the implications of the equation. Or did the waves crashing against the rocks give him the equation as well? I mean, I'd love to sort of, the romantic in me, in both of us, maybe wants the sort of nature to sort of there to be a kind of an epiphany moment when the waves hit the rock, and he has this intuition that there is something more at play. Or is it just that he knows the equation works, and then he goes out and starts to understand the massive implications of the equation?
No, I think that what happened there, it's a convergence of a lot of things. We sort of know what was in his mind. He was reading Goethe, the East and Western Divan, which is all about Goethe's love for Islam and sort of Persian spirituality and poetry. He was deeply immersed in philosophical thinking. Mach, don't believe your metaphysical prejudices. That was a message of Ernst Mach philosophy. In fact, the opening of the article he wrote to make his point, it's almost a citation of Mach. I'm going to write a new theory which is based only on what you observe and nothing else. So it's like questioning reality itself. And of course, he had all the physics in which he was immersed, which was the experiment about the atoms and the need to understand that. So I don't think it was the equations that led him to a vision. I think it was an ensemble of visions, ideas, intuitions, and equations and numbers that worked together in his mind to hint to a new way of doing things. And in fact, his idea was, the problem was understanding atoms. There's a lot of new data about atoms from spectroscopy, from experiments, and they were just very hard to make sense of. And everybody was trying to make sense of this with the old methods, by a new equation, a new force, a new equation of motion for the electron. So the electron is here, is pushed by a force. Which force could generate what we think? And he, in the incredible radicality that you can only have when you're 20, I think, he was 23, he just sweeps this away and said, no, we know the equations. We know this just electric force, nothing else. But the electron is not what we think it is. The electron is not a little particle moving around. We don't know what is electron. Maybe there is no particle there. Let's just talk about what impacts us. Let's just talk about the relation between the atoms and us and whatever is outside. So instead of thinking about things, he thinks about observables. That's the word he uses. I think a better word is relations, how the electron relates to something else, to another part of the universe. So it's a radical rethinking that motivates him to write equations differently. In fact, instead of using variables, he uses this matrices, this strange mathematics that has to do with what we see about the electron, not about the electron itself. Philosophical ideas, throw away some metaphysical assumptions, and I think strongly some poetical inspiration, because he was reading Goethe, he was learning by heart Goethe, he was immersed in this nature. He went alone, he was not in a university department. He was a 20 years old guy alone on an island in the middle of the Northern Sea without vegetation. He was climbing the rocks regularly. He was doing three things: doing calculations, reading Goethe, and climbing rocks. I don't know, maybe that's one recipe for discovery. Maybe it's not sufficient. You have to have all the ingredients in your head and to be Heisenberg. And of course, it's not just him. I mean, there was a community of people who produced all these ingredients that in his mind clicked together and produced this new vision of reality.
There's a beautiful line which I was very struck by reading, and which I think relates very much to this, but which I may read if that's okay. It's but at the molecular scale, the cutting edge of a sharp knife is as fluctuating and imprecise as the edge of an ocean in a storm, fraying upon the white sand of its shore. And again, this sort of beautifully encapsulates your sort of jump from your weaving of the macro and the micro, and this sort of the symbolization of them. But I think it also, for me, it really sort of shows up this idea of him standing at the shore, seeing this violence of the waves, but also considering the this subatomic kind of activity as well. As an artist, I think the sort of epiphany, the jolt, the sort of bolt of lightning kind of moment is something, as young people, we crave, and we kind of feel a sense that it is something that we all will get at some point, and some people do and some people don't. But I'm sure you've had many over your career and as a child. And when would you say was your first jolt? When was the first? What caused it? Was it something you read, something you were told, something you experienced? And how old were you?
It's a nice question. Thank you. I'm not sure. Let me give you a few steps. When I was a child, I used to, I was a complete normal child. I used to, my parents would say, ero incantato in Italian. I don't know how I would translate in English, enchanted. I would start looking at something and just not answering question, not reacting, and being completely taken by observing something. My parents always reminded me about that. I always had the impression that I could not get to the bottom of what I was looking. There was something else to look at. And I had a very stormful and restless adolescence. I was very confused. I was instinctively, in the way that many adolescents do, questioning what was around me. So I was looking for questions all through my young years, but a dramatically strong moment of realizing that the picture we have about reality, the common picture we have about reality, is just one picture, not necessarily the best one. Was at 16, when completely unaware of anything, I had first time experiences with psychedelic drugs. It was very, very strong on me. I was young, 16. And it was a few hours of seeing reality completely differently. I was aware it was just a chemical thing in my brain, but nevertheless, everything is a chemical thing in my brain. So it left me a strong sense of, okay, we see the world, and it's very good. It's a very good way of organizing things around us, very, very effective for me. I mean, this is a computer, that's a chair, that's a window, all makes sense. But that's not the bottom of the story. That's just one organism. It's just shadow of something else. And who knows what is behind those shadows? To some extent, we can see, we can learn, and science is about decoding the shadows to some extent. But we find other shadows, and then other shadows. And I think we should be aware of that. And the more we are aware of that, the more we can learn about this beautiful world of shadows in which we live.
Fantastic. I think my first sort of iota was I was quite grumpy because I was very possessive of my weekends, and I remember the clocks going forward one weekend, and I was not looking forward to going back to school on a Monday as kids don't. But I remember the clocks going forward and being conscious of it the first time and feeling very robbed of this hour that had been taken on my Sunday, but I was very upset and I was like, how do they have the power to do that? Who can afford? I was totally indignant about this, and I felt that this was impossible. And but it started me thinking about it from an early age about how incomprehensible that could be and how could the government do this. But obviously, yeah. So that started me on a pathway of questioning things.
So for you, it was a rebellion against reality. You didn't want it to be as it is, in some sense.
Well, I was just amazed. I was amazed at the power that time could be moved forward, because the clock seemed this very authoritarian thing to me there, and obviously it's just arbitrary, but it seemed so absolute. So the idea that someone could push it forward seemed impossible. I was 5 or 6, so it was at that time it was just, but it started me on that journey of questioning of something about whether things were actually this authoritarian thing that was in every school classroom or that governed our lives was actually not real. And so I suppose that was the beginning of a sort of a questioning. I wanted, as I'm Italian as well, and my grandmother was from Molfetta and my wife is from Milan, I was interested in the journey that you take from writing, thinking in Italian, and then the books arriving in now 43 different languages. That's incredible, diverse audience, and I imagine you're not able to read all of them, but certainly the English is really interesting to me. The whether you aspire to make the book a facsimile of itself as much as possible, or whether you allow the book to become more akin to the language that it's being translated into. So whether it's more poetic or less poetic, more scientific, and how you go about that idea and that challenge.
My mother language is Italian. I grew up speaking Italian, and then I spent a lot of time in the Anglo-Saxon world. So I I started using English more and more, and using English professionally more and more. I've been writing in English physics for all my life. When I started writing books for a larger public than the 20 people who read my technical papers, I realized that it was easier for me in Italian. Because I was still far more fluent in Italian in writing than in English. As soon as we sort of go out the technicalities of my work, but at the same time, I realized that my Italian had been influenced by a long life in the Anglo-Saxon world. In fact, my use of sentences in Italian is more English than in Italian. So it was I wrote these books in Italian, but in a way which is truly a mixture of the two. And then I had the incredible fortune that the translators of my book are extremely good, extraordinarily good. I would say uniquely good. It's a couple, a poet and a person who studied translation, who did a marvelous job in translation. And so I read English good enough to appreciate the English translation of my own writing. And I see that it's not the same. And to translate is not to do the same in another language, because every writing, in my opinion, it's creative. Even if you write simple things, you're creating new structures within one language, and when you move them into another language, you're creating something within the new language which enriches this new language. So a translation is a new word, is a new work, a new something. Yeah. It's like, a piece of music which is replayed. It's a new piece of art which is different from the previous one. And so I love the English version of my book. I feel it's not just me, it's also the translator, and it definitely has something which the Italian does not have, and vice versa. Mm-hmm. And that's good. That means that it's a great translation. I think exact translation is impossible because languages are truly different.
And it would kill it. It would kill.
It would kill it, exactly.
I think there's a paradox. There's a sort of paradox. It's a bit like your house. In order for something to remain the same, it needs to change.
Exactly.
If you stop doing things in your house, it just sort of dies to death. But actually, the way for things to remain the same is that they change. And actually, I think it's an important sort of paradoxical rule.
Exactly. That's a great analogy. Imagine if my house in Verona, I could rebuild exactly here in Canada where I am now. It would be just death, right? Pure death. Yeah. To be alive in the way it is in Verona, it should be different. Because things are not what they are, right? Only they are the way they relate to what it's around. So that's exactly the point. You cannot isolate something, and you cannot isolate the content of a book from the language, the culture, the world of evocative things around it, which changes as soon as you move it around from one language to another.
Yeah, and I think there was, I haven't prepared this, it's a bit of a tangent, but there's something about the radical way that we age is also a way that we somehow remain the same. I know that it's with objects that don't change, they change so much more radically than the things that aging is a way of remaining the same. It's a sort of counterintuitive argument, but anyway, I haven't prepared you for that one yet, but I wanted to go on to the symbol for quantum mechanics, for the theory, the psi symbol. And it's the sort of way that my brain works. I just sort of look at things in a quite structural way, and I was really intrigued by it. And I didn't study ancient Greek, so I looked up its etymology, and some people describe it as a chicken foot, some people describe it as a candlestick. But to me, it really looks like a trifurcation. So I would use it as a sort of one going into three. It's almost like it also could be Poseidon's trident.
Trident.
But what I love about it, and I don't know whether it was a coincidence or it's subconscious, but did he choose the symbol because he potentially unconsciously knew that this might represent this idea of these multiverse implications, that things were going to just basically proliferate from this moment onwards? It's such a wonderful, it looks like such an anarchic symbol to me, that it shows that this is this impossibilities of the cat being alive and the cat being dead and sleeping and awake. So it just shows this sort of, I don't know, there's something exciting there, but I don't know whether it's just a coincidence.
I don't know why. This is Schrödinger who chose this letter. I don't know why he chose it. It's certainly in the moment he started using it, it's also the moment in which his side, I mean, this symbol represents the possibility of the electron of being two places at the same time. And which also means that the actual possibility that the same present evolve in different futures. So the trifurcation, not just two, but many different futures. The loss of determinism, which characterizes quantum physics with respect to classical physics. Somehow we have reinterpreted the classical physics at the light of quantum theory, just because, you know, certainty just averages over uncertainty. But the reality is that the future is open, and many things are possible given the same present. In some strange way, even the past is open given the present. We cannot reconstruct the past from the present either. I don't know if Schrödinger had these resonances in his mind when he chose this letter. Maybe not, because he probably didn't yet know how radical was the step he was taking. This is the year, 1 year after Heisenberg. Schrödinger also is it's doing this main step, is writing the Schrödinger equation, which is the other root of quantum theory. He's not in the physics department either. He's in the in the Alps in Switzerland. In fact, in a love escape with a lover, secretly. Still today, we don't know who is the girl, the fortunate girl or woman, I don't know, or young woman. It has remained, her name has remained secret. But Schrödinger and her went up in the mountains and did what they had to do, and probably also hiked in the mountains. And when he came back, he had the psi, the Schrödinger equation, and a big piece of quantum mechanics.
Right, okay, fantastic. I was going to, talking of I wanted to talk a bit about the ideas around the rebels of science. And I suppose when I was at school, I did maths and physics at school. I was a poor physicist and a poor mathematician, but I loved it for the ideas that it threw up and the questions it raised. And I suppose, but I was taught maybe in a way that was quite it was a bit conventional. And I loved the philosophy and the things it sort of challenging my sense of what's real. And so I suppose that rebel thinking of the paradigm shifts and this idea of collapse and things, which is a lot of my work is very much about collapse and this idea of sort of creating instability. And maybe at this moment I could show the Crick piece. May I share the screen, Martin? Oh, great. So that's up there now, is it? Okay. So this is the piece that called Paradigm, which is outside the Francis Crick Institute, and it's this stack of tetrahedrons which get bigger as it grows up, and it was really named after Thomas idea of paradigm shifts, and that this object which carries on growing, the argument carries on getting bigger and more mighty, and as it gets stronger, it becomes more prone to collapse, and that for science to succeed, it really needs to allow its generations and its community to challenge even the most sacred of its principles, and that these things, if they are torn down or if they are toppled, is the only way that things can grow and progress, and that there have been moments in the history of science where things become too sacred and are not allowed to be questioned, and that's where things can really be stifled. And I think if I understand a sort of motivation of the book, which I would love you to expand on, is there is this, like with Copernicus 150 years ago, there is this call to to try and allow us to sort of open up our ways of seeing our and sort of take off the blinkers to us, to realize that our perceptions are not complete, but actually very limited. And that the more we can understand the limits of our perception, the more we can build quickly our understanding of how the world really exists. And you've beautifully used the analogy of Copernicus, and it took 150 years for our brains to get round the fact that we were hurtling around the sun at millions of miles an hour, and we were on the surface of a sphere, and we were not at the center. And perhaps you could talk a little bit about how that journey towards, which we now all take for granted, most of us, but maybe tell us about the Copernicus journey in relation to quantum mechanics.
Yes, absolutely. And I think when Heisenberg, to go back to Heisenberg, when he made this step, I said he was reading Mach, and he was deeply under the influence of Mach ideas, which were all about that, namely, don't give for granted what you think is given for granted. It's the same motivation of Einstein 10 years earlier. And in fact, Einstein was a hero for Heisenberg. Namely, things that seems completely obvious to us might be just wrong. And Copernicus was so hard to digest for the world because he had an understanding of nature where we are not, the Earth is not still, the Earth is moving. And in fact, it's not just moving a little, it's moving at a crazy speed. Just the rotation of the Earth means 10 kilometers per second, just crazy speed. And how could that be when it's so obviously not moving, the Earth around us, right? So this required an entire rethinking of what to move means, which took, as you say, 150 years or more for the European way of thinking to adapt to it, and then for the world way of thinking to adapt to it. Now we are comfortable to the idea that we're sitting on a spinning rock, huge spinning rock. And when we see the sun setting, the sun is not setting, it's just us moving back from it, getting into the shadow. Heisenberg did the same with respect to the idea that the world is just, some space where some little particle move and bounce around. No, the world is much more complicated than that. That seemed to be working very well for 200 years or more, but just doesn't work for understanding atoms. Reality is more complicated than that. It requires questioning. And as you say, this questioning requires a radical rebellion. There's something, and that's what has fascinated me in science since ever. There is something of the deep rebelliousness that makes humanity, because humankind did everything it did and has everything it has because it rebelled against previous ways of doing. We tend to remember that all things we like and love come from rebellions with respect to things that previously were considered right and sacred and untouchable, and so on and so forth. That's what fascinated me in science, this capacity of rebelling. Why? Because the capacity of rebelling allows us to produce better way of thinking. And what puts us on the right track is not just rebelling freely, because it's an intelligent rebellion, it's a cultured rebellion, that of Copernicus, of Einstein, of Heisenberg. It's not just saying no. To the contrary, it's a deep immersion in the knowledge of their time and finding the cracks where it doesn't work, right? The details that don't match. And in fact, Conrad, in your art, and in your tetraedra, in your cubes, in your geometrical figures, what I love is exactly this not matching, which you sort of make it visual, make it look. I work with tetraedra. Here's tetraedra and cubes, and also, this seems one of your art, I think. It's a little piece of paper with a and almost concretely, maybe I am overdoing this, but almost concretely, the point is that when you look at, I work up my own work is on the quantum properties of space itself. And you can think a space of many little tetrahedra like that, which, however, don't match, because that's quantum mechanics. The quantum mechanics is related to the non-matching of one thing to the other. And this is what I see in your non-matching geometrical figures. And this cracking, this not getting together, it's perfect. Why? Not because it's just confusing us, but because it's destabilizing us, and it allows us to make a jump, not to jump toward the absolute truth. I don't believe in absolute truth, but to find a crack, an opening through which we can see something more, another layer of reality. And this is, I think, the what happens in these revolutions. They're not revolutions that tell us what we know before was wrong, because of course what we knew before was right, but a lot was missing and was imprecise. And to understand better, sometimes we have to redo things from scratch, reorganize the basic of our way of thinking reality. And that is what happened with Copernicus, with the notion of moving or not moving. And that's what happened with Einstein, with the notion of a fixed time for everybody, the same time for everybody, which we know is wrong. And that's what happened with quantum physics, even in a deeper sense, because the idea that the world is made by matter with properties just doesn't work. We have to think matter in terms of relations, and that was opened up by these cracks in classical mechanics that were coming out more and more clearly at the beginning of last century.
And these thank you. That's fascinating. These works that you see on the screen now are they're called schisms, and they're made of 80 equilateral triangles, which, as you all know, would form a perfect plane. And then those 80 equilateral triangles form 20 tetrahedrons, which Carlo just held up one. And there would be there's a sort of assumption, because it's such a regular form. I've got one here. It's such a regular form. It's the symbol of, in ancient Greek times, of the symbol of the atom, and it's this basic unit of matter, this sort of unobtainable idea that everything is built from this. So, and you would assume that this thing would, and when I first got lots of them together, I was very naive. I hadn't done any prior research. I expected it to be able to make a bigger tetrahedron out of smaller tetrahedrons, like you can with cubes. And I was baffled by the fact that it was completely unruly and formed these cracks, and I thought maybe I'd made them wrong or something, and I sort of put it aside because it failed, and I couldn't control it. But then over the months and years, I realized this is not to be put aside. This is amazing, and it's amazing that in its failure, it challenges whoever looks at this, whatever they assume to be real, whether you're a priest or a Brexiteer or whatever you are, or whatever, or a unionist. It shows this dystopic, or that something's not right, or there's something much more going on than we realize, because it's I don't know. It's very what I love about it is I don't know what it means, and there's something in it that is very profound, and I just don't know what it is yet. But it's also actually follows on to your wonderful arguments about relational quantum mechanics, because I think the point about this is that you look at this, and every 800 of our audience are looking at these objects, and each one of them, based on their education, their experience, their race, their gender, their ethnicity, their love, their trauma, they look at these objects and they see something different, and each one has the potential to have this infinite number of reactions and interreactions. And that's maybe a great point for you to tell us about relational quantum mechanics.
Yeah. Thank you for this this point. This is near Marseille. This is the place where I work. This is
this one you can enter into. You
can enter into the crack, which is a dream of every scientist, to enter into the crack and see what's inside.
It's just suspended above the ground because of the geometry.
Let me put it this way. Let me start from the art. For people who are not artists like me, naively, there is something something disconcerting, right? Because you're showing that what it is a piece of iron attached to it. I mean, so what? What's the point of a piece of iron? A piece of iron is a piece of iron, right? Nothing else. What else? But you can see this of every work of art. It's just a piece of, Michelangelo's statue is just a piece of stone by itself. The point is that, of course, a piece of art is not the object by itself. It's the way the object itself interacts with me and with other people. So its reality is not just included in itself. It's the way it reflects to what is around. And it reflects what is around given the culture, the ideas, the eyes, the ears, if it is music, the full complexity of what is around. And then it becomes a significative, evocative, and then it has power. And it can have great power, immense power, because it touches us. It steers our emotion, our thinking, our sometimes our entire being, because strong art can have a strong effect on you. It puzzles you, it intrigues you. And where is the thing that intrigues you? Is not just in your mind, because there's the art there, but it's not there either, because that's a piece of wood or a piece of stone, or just a sound, which is some oscillating air molecules. I mean, why oscillating air molecules should move me? And yet I listen to Beethoven symphony and I cry. It's just definitely moved me. So where is art? Is it in the relation between the thing and me? And one is tempted to say that this relational aspect of things, it's only at the higher level of our complexity, our meaning, but it's not true, because all of chemistry, it's about oxidants or acid or bases, which is how.
Got a cat here, so there's definitely alive. This cat.
That's Schrödinger. It's very alive.
He's not asleep. Sorry.
So relations is the way we think also in chemistry. How elements, what an element is the way we react to other things. And one is tempted to think that once you go to physics, down to the elementary objects, that's it. An atom is not relational. It's just what it is. And I think my understanding of quantum theory, and that's a full content of the book, some of the main message of the book, is that what we understood with quantum theory is what Bohr called contextuality. It's the fact that it's relations all the way down. Namely, an atom by itself is nothing if not in relation to the external. So we make a mistake if we think of the world just a set of entities with properties. A better way of thinking about the world, it's to understand each entity in the way it relates to what is outside. And that's the deep message of quantum physics, in my opinion. Namely, when Heisenberg got his new mathematical description of atoms, saying, I describe what we can observe about atoms, observables. What he was describing is, what he was realizing is that the best description of nature is not separate objects, but how objects affect other ones, interact with other ones. In a sense, without interaction, there is nothing to say about reality. Things are the way affect one another. This deep relational structure of reality, it's, in my opinion, the best way to make sense of quantum physics. And so in the book, I try to describe this all the way through. And I started from art because it's not that it's a sort of new idea that things are relational. Of course they are relational, right? What is remarkable, and that is the immensity of the quantum revolution, is that things are actually relational all the way down, including the elementary constituents. As far as we know, the best way to think about nature It's about relation between things, how things appear to one another. So in a sense, we're living in a, to make a metaphor, in a world of perspectives, of visions, of relative respective images in which things are a mirror of one another. We understand the world better this way than separate entities with properties.
Yeah. I was going to read another ending of this is the end of part 3, and it's very much related to this. And I think this is a sort of deeply radical text. It's very coherent, and but it's still let me read it and then we can discuss it. Properties do not reside in objects. They are bridges between objects. Objects are such only with respect to other objects. There are nodes where bridges meet. They are nodes where bridges meet. The world is a perspectival game, a play of mirrors that exist only as reflections of and in each other. This phantasmal world of quanta is our world. I mean, it's deeply, it's radical. I mean, it's amazing, and it's exhilarating. But tell me, I mean, you've really sort of talked about it already, but would it be very trite to say, tell me please if this is really trite, but the space or the silence between the notes, is that related in a piece of music when you say Beethoven or you talk about Bach, or in terms of the notes not being important, but the connection between them and the silence between the notes is actually more important than the notes themselves? Would that be an analogy that you could use here, or is it too trite?
Yes, it definitely is. It's in fact, I think it's a very good analogy. Take your preferred piece of music, or a simple melody. Take your preferred melody is a collection of notes. Each note is just a note. It has not much interest. It might be a nice sound, but it's definitely not there. So where is melody? Is not in any of the notes. Exactly. So where it is in the relation between them.
And there's something wonderful as well about music in the way that a note is affected by the note that comes after it. So there is this sort of sense that time doesn't work in just one direct. There is this sort of non-linearity to it, where a note will mean one thing until the next note changes the meaning of the one before.
It gets a meaning from what comes after.
It's a bit like German or something, where the German is the same. The last word in the sentence changes everything at the beginning of the sentence. You have this really interesting kind of way that it's not linear.
Yes, and it works. Of course, if you think for a moment, it's not in the music, it's not in the sound, it's in the effect that the sound does on our brain, because our brain, as it was noticed long ago, if you listen to a melody, in every moment we're just listening to a note. Mm-hmm. But then something happened that we remember the previous notes, and our brain sort of grasped toward in anticipating to the other ones, and it can be either sort of guessing right or guessing wrong. And a lot about the music is a game about satisfying your guessing right and not doing so and surprising you, and the surprise changed the meaning of what came before. Yeah. So it's a complex game of relations and of meanings, which makes the music. And once again, we recognize these things in our own thinking, but to recognize that the grammar itself of nature works like that is the magic of quantum theory, in my opinion. Somehow, with classical physics, we thought, all right, so this is just a higher level description of things, but down there is simpler. Down there, just this little stone bouncing on one another, and that's it. Each stone has a position and velocity, and that's it. No, I mean, the single elements, as far as physics it's capable of describing, they also get meaning by interaction with something else. And the key point, and that's the key point of our book, is that this perspectival is not with respect to us humans or to the mind. It's just with respect to other pieces of reality. So it's not a subjectivity thing. It's just nature itself that works this way. So I know this I don't know if it's called pieces of your installation. I don't know what the name of these things.
It's called slow arc inside a cube.
And that's can you make it run? Is that
yeah,
oh yeah.
There you go. This was the first one that I made. Yeah, and it's I mean, I suppose just before we leave that idea of relations, to take your metaphor of the nodes and the bridges between the nodes, or the silence between the notes, under these bridges is the exciting thing in the next 100 years that under these bridges is running all this dark matter, this thing that we will suddenly become aware of, that is going to be this huge new era for quantum mechanics. Is this the sort of, are we at the threshold of a new dawn in terms of that?
I want to see also. Yeah, wonderful. Also this one.
So that the first one is a single light and single cage. This one, and they started off as quite minimal kind of attempts to create these disrupt space and disrupt the solidity of the architecture. But actually, I felt a bit guilty about putting a double light in there, because it was sort of felt like it was overcomplicating it. But actually, the fascinating thing was it instead of it lurching from side to side and being very disorientating, it suddenly became very balanced, and there was this sense of equilibrium and poise and harmony. And even though they're moving at the same speeds, there was this sort of cancelling out of this overall, the speeds were sort of cancelling themselves out and compensating for each other. So it was an interesting effect of the sort of doubling effect. Then the third one was this is a double light and double cage. So they sort of get journeys towards complexity. And actually the impetus to make them minimal at first became almost, I suppose, having talked to you last week and things, was they are almost, I'm sort of interested in them becoming these simulations, but at the same time you can see the object that creates them and the effect. So you're both able to be in this sort of this impossible position inside the universe and beyond it. And so I think in terms of, again, this idea of subjectivity, in terms of never being able to escape the experiment, the observer being, which you write again about very beautifully, about always always affecting the experiment and always being part of the experiment. So I thought these were quite relevant in that regard. This is the final version, which has three cages and 2 lights, and then the inside of the cages are painted with the primary colors that are orientated round, so you get the 3 colors on every face that creates this prismatic effect on the inside. But the shadows are very. What's lovely is that as the complexity has grown, the shadows, the harsh rhombic tiles, the angular shapes of the tiles have been replaced by this liquidity, this sense of water flowing, or the dappled light of the sun through a dense canopy of leaves. And there is this sense of it's kind of almost creating something very natural or organic through the surprisingly simple mechanism and components.
Let me say a couple of things about that. I love these things. I love this moving shadows and this. In fact, I'm completely fascinated by this. And my reaction is this: we're completely absorbed by these moving shadows, and they so much, as you say, started assembling reality. And in fact, they are a part of reality, right? We are just seeing them as we see, as you were saying, the shade of the leaves against the sky. If you lie in the grass looking up, and one is tempted here to say, oh, look, there are shadows, but these are just shadows of a real object, which is the center. So the center object is this metal cage with lights, which is real, and the shadows are fake. But then one thinks and says, well, is that so? In which sense is the shadow more fake than the image of the cage that I see directly? They're both just effects of light bouncing on something and getting to my eyes. So when I look at that, I feel how shadows are shadows, and how the cage itself is a shadow of something else, and the light itself is a shadow of something else. And they are all parts of this interacting set of things, which arrive to me just because I am part of this bouncing set of relations. And that's what I find so fascinating. So I feel I am one of these shadows bouncing around, and I can. You mentioned you being under a tree and seeing this complexity of geometry created by the relation between things, and this almost remind me this, me 16 years old in Paris in a park, and looking at things, looking at my hands, and seeing them as images of something which I don't know it is, and me myself being part of this respect, this exchange of views, which are all partial, but that all together constitute reality at best as we can describe it.
Mm-hmm. Yeah, and I think what's powerful, hopefully, about this work is that there is this, by being able to see both the mechanism, this platonic ideal, plus the kind of Plato cave kind of reality of its projection, is that you by being able to see both simultaneously, you, particularly with the more complex works, you realize that we will never be able to understand everything that in the universe. We will only be able to infer ingeniously, of course, things around that corner or beyond our perception envelope, but it will never be real. It will always be shadows of the real, and it will never. We can only just hope, but through our attentive, ingenious sort of methodologies and tenacity to sort of understand and peel back the onion a bit further. But I suppose one of the things in terms of the Copernicus argument is that with the universe, there is an appropriateness to represent the universe on these large scales using with light, because light exists in these realms, and so we can create simulations of the Earth traveling around the sun, and we envision these things very appropriately, and they're beautiful, and we understand them through these diagrams. But I suppose one of the things, and I hope it's where artists will play more crucial role, is how we represent the quantum world, which is beyond the wavelength of light. It's inappropriate for us to represent it in that way, but maybe it's the only thing we can do. But also the brain, the neurology, neuroaesthetics, all of these things, there is such a necessity for wild imagination to sort of try to represent these things. And I don't know how you feel that we should handle these challenges, because I guess it's things that will never be seen. How do we represent visually things that will never be seen?
I think what happened in Europe in the Renaissance with the Copernican revolution was that slowly the sort of the perspectival aspect of our view of the solar system. We're viewing the solar system from within somehow, not from the center out, but from a moving body, slowly entered in everybody's way of thinking. And art itself, from poetry, Milton, to visual arts, have absorbed that. Quantum mechanics is a comparable revolution, in my opinion, and it's not going to change one thing. I think it's slowly going to enter into the way we think about reality, and enter in resonance with the work like the work that you're doing, and slowly allow us to think in these sort of relational terms. What I would like to say is that, and this takes us to the beginning, perhaps, of the conversation. I think it's wrong to think that we get to the bottom of a complete description of reality. So there is always this incompleteness, the part we don't know, and that's because we don't know it de facto, and also because it leaves our mind open to understand better. And at the same time, we learn so much about reality. I mean, I can say so many things about your shadows, and they're true, and the way it works, and I can describe better and better and better. So it is this double possibility of having an increasingly deep understanding of the world, and at the same time knowing which is there is a perspectival aspect about it, and a deep incompleteness about it, which I think it's something we should absorb, and it's in my opinion, is beautiful. It's or perhaps it's just me. I mean, I'm attracted by something which is not solid rock, but it changes, it evolves. Its life is not dead.
Okay, fantastic. I think we're running a little bit out of time, but I wanted to just ask you on the final chapter of the book. Before, I think you would you like to read a little bit from the last page? The last chapter talks about the nature of vision, and I was someone who's been very interested in perception and the nature of perception. I was fascinated by this, and at first it seems counterintuitive, but it's actually really brilliant. The idea that our brain starts to see in reverse as we become familiar with things, and perhaps you tell us a little bit about this these new discoveries in neurology.
Yes, thanks. It's something that I'm just reporting from neurosciences, is some recent development that completely fascinate me, and I think that is interesting because it's a metaphor for how our knowledge, how our science works, and how our knowledge works. And it's discovery that, at least it seems so, that the way vision works is not really that there are things in front of us, light goes to our eyes, the retina detect the photons, decode things, find shapes, sends information to the brain, and the brain recognizes things. That's not really just how the vision works. Vision works to a large extent the other way around. Namely, most of the time, we know what is in front of us. I know there is a camera, computer, a microphone. Here's a microphone. So if I look here, I expect the microphone. So what the brain is doing is sending down to the eyes the information, that's a microphone. So you should expect something green and something gray and this and this and that. So a lot of information goes down, and the layers of our neural structure, which are closer to the eye, compare this prediction with what gets in. And if it matches, that's it. It stops. It doesn't send up to the higher part of the brain any information. It's only when there is something that doesn't match that some information goes up and say, there's something that doesn't work. Okay, and then, maybe the microphone has fell down. It's not there anymore. Maybe it has mutated in a tiger suddenly. Maybe, I don't know. So we don't really see in the sense of taking in. We project it on the world, some image, and we look for discrepancy. And if it doesn't work, we try to figure out something else. And that's how science works equally. We have theories about the world. We try to interpret the world. And it's when something doesn't work, which we are forced to rearrange things, which means that what interests us really is not what confirms what we think, but what disconfirms what we think. It doesn't match what we think. In a sense, one could say we're living in a dream that is constantly confirmed, and we have to readapt our dream when it doesn't work well. I don't think this makes our vision of the world less valuable, less interesting, less has less sense for us. But it keeps it, we have to keep it fluid.
It makes perfect sense in terms of things that we do all the time, like drive or ride a bicycle or walk along the road. We do the same journey 1,000 times, and we're not really aware of the fact we're doing it. It's the muscle memory and our just that we're sort of programmed to do it. And it's only when something extraordinary happens that we just jolt out of it. And again, it's such a good endorsement of the idea of creating something of beauty, because whether you see something natural or man-made or cultural, those things can suddenly jolt you out of something, create a whole new, entirely new neural pathway in your brain through the experience of something original. And so it's such a great kind of amazing kind of inspiration to artists to hear that and to sort of read that, because it's just so, it just makes me very excited to carry on trying to do what I do. I was also finally just, I'm aware we're running out of time, but I was also very excited because I read this, I was at the weekend, I was with my 6-month-old niece, and I was just read this chapter again, and I was watching her bright-eyed and sort of amazed at everything around her. And I was thinking about this way her brain was working and her eyes were working. And at that age, you're just absorbing everything. It's almost overwhelming. And there's this tide of information just zooming into this young brain, and it's absorbing. It just can't really remember anything because it's just processing all this stuff. And as you get older, that tide, I guess, begins to slow. And at a certain point, as you reach maturity, that tide starts to turn, and you're able to operate in a complex world and formulate ideas and complex thoughts, because you have this ability to do what you're saying in terms of the brain feeding the eyes rather than the other way around. And so there's this, I saw it for real with my niece in this amazing kind of sponge-like absorption at that age.
So let me just try to close saying that I guess my wish is that we can be like the 6-month-old girl a little bit, even in later years, being an awe of what we see and being open to reabsorb it and change our mental structure. That's, I think, what the best science and the best art is.
Well, it's been so inspiring talking to you. Do we have time for you to finish with a line from the book, or are we running out of time? Yeah, okay. Is that okay? I can't hear you. Yeah, it's good. Yeah, it's good. He's giving me the thumbs up.
Just since it's late, just this connect to what we were saying just now. Every time that something solid is put into doubt or dismantled, something else opens up and allows us to see farther than we could before. Watching what appeared to be as solid as a rock melt into air makes lighter, it seems to me, the transitory and bittersweet flowing of our lives. The interconnectedness of things, the reflection of one into the other, shines with a clear light that the coldness of 18th century mechanics could not capture, even if it leaves us astonished, even if it leaves us with a profound sense of mystery.
Wonderful. Thank you.